Hello there guys, and welcome to video number 170. This one is on negative scale factor enlargement. The keywords I've got for you are enlargement, scale factor and invert. So an enlargement is when a shape is made bigger or smaller in some sort of space, or normally in a coordinate grid. Scale factor is the thing that makes it bigger. So if it's a whole number or an integer, that means that you're going to get an enlargement that becomes bigger. But if you use a fraction, that means your enlargement is going to become smaller. And the word invert means to flip inside out, basically. So the image will be inverted, therefore it will be a flipped image. Now, the method states to enlarge a shape or describe an enlargement, you need two things, same as the enlargements that you needed before at foundation level. This one is higher only. You need the scale factor, that's how many times bigger the shape is, as I mentioned, but negative ones do something specific. They make the shape bigger, but they also invert the image. They flip it inside out. You also need the center of enlargement, where it could be given to you as a coordinate in a coordinate grid, or just a point in some space or another. And you'll need to use projection lines, as I mentioned before in the other video on enlargement, to find the center of enlargement point if you've got to do a description of the transformation. Okay, please watch that other video first before you watch this one if you haven't yet done so. Now, question number one states to enlarge, or asks us to enlarge shape A using a scale factor of -2 from point P and label it B. So I will zoom into this shape now, and so you get a nice close look at it. And I will get my line tool up. And what I'm going to do is I'm going to do my county squares method, all right, of getting from point P, the center of enlargement point, to one of the vertices of the shape. Choose any one you want. So I'm going to go to this corner here. All right, now I'm going to start here. I'm going to go one to the left and one up. One to the left and one up needs to be multiplied by -2. Okay, this distance here. So one to the, do it one square at a time. One to the left will in fact become 2 to the right. Okay, because, and I'll just do that in different color. All right, 1 multiplied by -2 becomes movement in the opposite direction. Okay, and the same with the movement up. So we've gone up 1 square, we're going to go down 2 squares. Okay, there we go. Now I'm going to mark that with a blue pen. I'll just show you the point that I got to there. Just get the other tool up. That point is now there. All right, on our enlargement. And what we'll do is we'll count the squares to get to the rest of them. I think it's the easiest way to do this, because otherwise it can become a bit confusing. All right, so I'll just use my blue. I won't draw the rest of the lines on it. You don't have to draw these lines on it. That's just showing you how we got that first point plotted. So I'm going to go 1 to the left and 2 up would become 2 to the right and 4 down. Okay, just multiplying that distance by the scale factor of -2. All right. Just going the opposite way with it. That's what you have to remember. All right, and then 1, 2, 3, 4 squares and 1 up. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Doubled it, but in the opposite direction, and then 1, 2 down. Okay, and then what you should see is that the other point obviously has to go there. I'm going to join those points together and draw the shape, and then label it what they want me to label it. They want me to label it B. Okay, and what you don't necessarily see here is that it has been inverted. All right, it's difficult to see because it's a rectangle, but that means that that point has gone through the center point there and is corresponding to this point here. Okay, and this point obviously was this point here. This point goes through that point and that point there, and this point through this point and this point here. Okay, and it's really difficult to see that's inverted, but what I'll show you in the next question is what it looks like when it's a triangle. Okay, because this shape here is a triangle. So question 2, we've got to enlarge shape C from the origin by a scale factor of -1.5. So shape C is a triangle, a little bit more difficult. Origin just means from the center, and scale factor is a little bit more awkward because it's a negative decimal number, 1.5. Okay, but no different, same process. So we'll go from the center, and I'll just choose any of the vertices. Oops, that's not something I meant to do. Let's just get that in with the line. There we go. So that vertices is the one I've chosen, that bottom corner of the triangle. 1 to the left and 2 up, little squares this is. This is not the whole units. That's half a unit and 1 whole unit according to the scale on the axes. But I'm just going to refer to the little squares because I think it's easier to to do it with the little squares. So 1 little square left will become 1.5 little squares to the right. Okay, 1 times 1.5 is 1.5. All right, and then the 2 little squares up will become 3 little squares down. All right, 2 lots of 1.5 would be 3, isn't it? There we go. So that point there, and I'll just get the blue back, and I'll plot that just with a little mark. All right, it's not technically how you plot things, but little mark there. There's our starting point. All right, now let's just do the same thing we did. So 1 across and then 3 up would become 1.5 to the other way, and then 4.5 down. So 4.5 would be 1, 2, 3, 4 and a half. So we're going from here to here, all right? And then we've got to decide 1, 2, 3 across, 1, 2 up, 1, 2, 3, 4 and a half across, 1, 2, 3 down, all right? Take your time on this, all right? It is tricky, really tricky to get it right, I think, but that's how you do it, okay? I think the little county squares method's the easiest. If you want to count the whole units, do, and if you want to use your calculator, do. Okay, but what you can see here is that most definitely the image has inverted. It looks like it could have rotated, doesn't it? But it looks like it's rotated and got bigger at the same time. So it can't just be a rotation. So the way that you would understand these ones is you go, oh, well, it's got bigger, so it's definitely an enlargement, all right? Or it's got smaller, it's definitely an enlargement, all right? And then you figure out where from, etc. if you have to do a description of it. All right, so yeah, definitely flipped the image, so we're happy with that, and it's definitely got bigger by a scale factor of 1.5. Okay, so that's that one, and I will now just zoom in to the last one and try and help you understand that one now. So this is a description one, as I've done for all of my transformations so far, always a description one for the third question. Describe fully the single transformation that maps B onto A. So what I'm going to do here is I'm going to get the projection lines in, because what we want to find is the center of enlargement point, where the enlargement occurs from. And we're going from B to A. And what you can see is that B is bigger than A. All right. So what we must be thinking of here is a fractional scale factor, and it will be a negative scale factor as well, because obviously it's in the negative scale factor video. But we've got to remember that. So this point here goes through the point 0, 1 and joins to this point here. Okay, now hopefully the rest of the points will go through the point 0, 1, because that's the only point that goes through on this coordinate grid, otherwise it'd be really awkward. Okay, so we're going to go from here through that same point and joins, and it does join perfectly to that corresponding point on the triangle, and then this point here goes through 0, 1 as well, all right, and joins to this point here. So we are very, very confident, or we can be very confident, that that point that I will mark with a little blue dot, all right, is the center of enlargement point. All right, now what we also need to figure out is what the scale factor is. So if we look at one of the sides of B, okay, one of the straight sides where we can tell what the units are, so 1, 2, 3 units, right, and then we look at one of the sides of A, or the corresponding side of A, which would be 1.5 units, we can see that this is half the size. Okay, this dimension and this dimension are half the size, therefore this dimension must also be half the size. So all 3 dimensions are half the size, therefore the scale factor is -1/2, because it's a flipped image. Okay, it's a -1/2. You can tell that it's not the same way round as what B is. If it was the same way round as what B was, then it would just be a scale factor of 1/2 enlargement from a particular point somewhere. All right, but this one, negative scale factor of 1/2 enlargement point 0, 1. Those are the things we need to write down. So I will do that, and I will do that with my pen that I can write nicely with. Okay, so I just move myself over there. I'll get the pen, and hopefully this will work, and just finish off the video. So enlargement from 0, 1, okay, using scale factor of -1/2. Okay, don't forget to put that minus in there. It's very, very important. You won't get the mark if you don't. Okay, so there you go. There's our video on negative scale factor enlargements. I hope all of that makes sense to you. It shouldn't trip you up if you come across a question like that in the future. Now, what I should mention is, I haven't done a video specifically on this, you might get a combination of transformations. But understanding everything that I've taught you in the transformations videos should see you well, and it should see you be able to piece all your information together. So yeah, if you feel like you need a video on that, I could always do an extra one. Just have to ask for it, all right, and I'll sort that out for you. All right, thank you so much for watching. Please do click the link in the description and practice, and yeah, continue to improve your skills in maths. Take care of yourselves, look after one another, and have a lovely day. Bye bye.